Hello friends, my name is Paul Agron, and today I'd like to start a series of videos on programming in Scala programming language. For this purpose, we're going to use IntelliJ IDEA with a Scala plugin installed. This is my favorite Scala IDE. There's also Eclipse and there are other options, but for the purposes of learning Scala, I think this is an excellent and possibly an optimal tool. So we're going to create a new project. We're going to create a simple Scala project. As you can see, there's a number of options here. So select Scala. And we'll name it something. Okay, it can be important to create Scala SDK. Here I've previously configured a Scala SDK. You might have to do it yourselves. So my Java SDK version is 1.7 and Scala SDK is 2.11.4. I'm going to finish that. And here I have a basic Scala project. So now that we have our project created, let us try to write a program. We could write a program by adding files and simply adding some code that we compile and evaluate, as we do in the typical type of programming. But for the purposes of learning, I would like us to use a fairly new feature to this IDE called a worksheet. So we create a worksheet by going File and selecting New. And here we have a Scala worksheet. The difference between a worksheet and a regular file is that expressions or statements in a worksheet get evaluated instantaneously, thus enabling us to program interactively. So let me minimize the left pane here. Let's try a very simple expression. Essentially, a number is a very simple expression. Let us try 55. If we give it less than a second, it gets evaluated to what is shown on the right hand side or in the right pane of the tool, and we see that the value of 55 is evaluated to 55, or in other words, the value of expression 55 gets evaluated to the value of 55, and the type of this expression is deduced to be an integer. On the right hand side, this means that, well, res0 means that this is a temporary variable that was created, and its type is integer and the value is 55. So let's try the classical string, classical to learning programming languages called Hello World, and let's give it a little bit, and we see that this expression is evaluated once again to a string Hello World. Well, let's try a more complex expression, and let's actually assign it to a variable. The way you specify variable assignments is you use a keyword val, then specify a variable name such as x, for example, and give it a value, 67, let's say plus 13. Okay, so x is evaluated to 80. Now, val is really a constant rather than a variable. So if we actually try to assign a value to the declared constant, we'll get a compile time error. And in fact, the IDE prompts us to correct this and to convert val to a var. Now, the way we declare true variables that we can change is through using a var keyword. So var xx, for example, could be equal to x. So xx is equal to 80 now, and we could reassign xx to another value. So what other ordinal types do we have in Scala? Well, if we assigned a floating point or a decimal number to a variable, it would likely be a double. Let's see this happen. So let's say s is equal to 99.9. So the system evaluates it to a double. We could also specify a type of a variable explicitly in this way. So types in Scala of types of variables could either be deduced whenever possible or could be specified explicitly for clarity. This really makes it different from a lot of other programming languages which either don't have types at all or where types always have to be specified explicitly. Here we have type deduction. In addition, we have tuples. Tuples are what is known in a functional programming jargon as cross-product types. Essentially, one can think of a tuple as of an array of a fixed size of values. So a tuple would be something like this. It is enclosed in curly braces. Right now the type of an empty tuple is unit, and we will revisit unit at some other point in this discussion or in a later lesson. But this is an empty tuple, a tuple containing nothing. So we could have a tuple with a value, let's say 12. So watch the result change to integer 12. That is because values, single values enclosed in a tuple are essentially values themselves. They're not special. Let's try to add a string here and call a 12. So now our tuple contains two values, and the type of a tuple is int, string, and its value is 12 and a string 12. We could also add our favorite 99.9, and let's call it an S. So this is a tuple expression. This can in turn be assigned to a variable, or to a constant. Let's assign it to a t. And so the type of our tuple, the type is described in a similar notation to the values. We could say that it's an int, a string, and a double typed tuple. Okay, so here we're specifying the type of the tuple explicitly. We could also describe it differently. Tuples can be specified in type language, if you will, through their type constructor. And this will be discussed later. All these notions such as type constructor in a type language will hopefully be described in later conversations. But let's say it's a tuple 3 because it contains 3 elements, and its types, so tuple is a parametric types, and its parameter types are integer, string, and a double. So this is the notation for parametric types, and we use square brackets. And we could assign the very same tuple here. But of course, now we'll get a compile error because we named our variable the same way here. We should really call it something else, right? We should not redefine a val. Okay, so we have yet another tuple. So how do we extract values from a tuple? Well, yet again, Scala is a very rich language, and there are multiple ways often to do the same thing. And in fact, this is for a reason, because different ways lend themselves nicely to different situations. So if we wanted to extract the first element of our tuple t, or of our tuple tt for that matter, we would say t dot underscore 1. So the dot notation in Scala really represents similar things to what it represents in other programming languages, and we typically dereference a field or call a method through the dot notation, similarly to Java and other programming languages, or C++, say. Okay, so obviously our tuple 3 has underscore 1, underscore 2, and underscore 3. There is no underscore 4. If it were tuple 4, we would see underscore 4, and analogously, if it were tuple n, we would see underscore from 1 up to n. Notice that indexing here is 1 based rather than 0 based with tuples. Okay, so we can extract values of a tuple through the fields of the type, but there is also another feature of Scala which is particularly interesting with respect to extracting elements. And this is a feature of many functional programming languages called destructuring. And it shows up in multiple variations in different constructs of a language. But here we can use destructuring upon assignment. We could use destructuring notation to extract values of our tuple t into variables a, b, c in the following manner. As you can see in the right-hand pane, values become available to our context in the file to be further used. So for example, if I wanted to print value of a, I would accomplish it in the following manner. In fact, print line is slightly better. By expanding the little plus on the right-hand side, we could see the result and the type of the result. So the type here is unit, an empty tuple, because print is just about a statement. However, Scala doesn't have statements. Everything is an expression. Scala is an expression language, and therefore print statement has a type unit. So if we wanted to use a different notation, as I already pointed out, in Scala we can accomplish things in multiple ways often. We could do it in the following way. This actually uses tuples type constructor. Our specific tuple is tuple 3, thus tuple 3's type constructor. However, here it would be wise to rename variables into AA, BB, and CC to avoid name collisions. Once again, AA, BB, and CC are available for printing and other operations. Now, it could happen that we didn't care about the first and the third element of the tuple, and Scala provides us with a very nice facility in the form of underscore to ignore elements during destructuring. So once again, we'll repeat the first extraction into A, B, and C, but this time we'll only extract the middle element. Call it Q. Once again, Q is available to further statements and expressions for printing. Here we could, for example, print 12 followed by something else. Thank you very much, my Scala friends, for listening to this introductory Scala lecture. Please feel free to visit my programming blog at www.fiberthread.com and be on a lookout for more lectures in the series.